solve, write a graph using interval notation. What do I need to do first?
Subtract 1 from both sides.
Subtract 1 from both sides. So I get
3x is less than 6, right?
Yep, 3x is less than 6. And then
You divide by 3 on both sides.
divide by 3 on both sides, and x
Less than 2.
is less than 2. So if I'm going to graph it, right? 2, 1. Is it open or closed?
Open.
Open. And which direction is less than 2? To the left. Okay. And so my interval notation would read what?
Negative infinity
To 2. Beautiful. Negative infinity to 2. Awesome. Questions? Okay. So number 2, what do I do first?
Subtract 3.
Subtract 3. And I get
Negative x is greater than or equal to 9.
9. And then what do I do?
I'm not sure if this is right.
Divide by negative 1.
Yeah, divide by negative 1. Beautiful. And what happens when I divide by a negative number? Inequality sign, yeah. So it was greater than, it becomes less than. Negative 9. Great. So negative 9, negative 10, and negative 8. Open or closed?
Close.
Closed. And which way is less than negative 9?
To the left.
To the left. Beautiful. Okay, and what is my interval notation?
It is negative infinity to 9. And negative 9.
Both parentheses?
No. Only the 9.
Only the 9. Beautiful. Only the 9 is a bracket. Yeah. Good. Okay, awesome. So the next 2, I didn't have to, I'm just solving and writing interval notation. I don't have to graph on this one. So what do I do on number 3? How do you get rid of everyone sitting there? How do you get rid of a fraction? Yeah, I multiply by the denominator. So I'm multiplying both sides by negative 3. So that goes away, and I get 2t minus 9. And I multiplied by a negative number, so my sign switches directions. Negative 21. Remember, my rule is multiply or divide by a negative number. So I multiplied by a negative number, so my sign switches directions. Are we okay?
Yeah.
Okay, and then what do I do?
Then you add 9.
Add 9 to both sides, and I get 2t is greater than or equal to negative 12? Negative 12? Yeah, negative 12. Divide by 2, and t is greater than or equal to negative 6. If it's greater than negative 6, that means negative 6 is my smallest number, and then it goes to positive infinity. Done. Questions? Okay. And then number 4. Okay. I guess I'm going to distribute a couple times, right? So I've got 19 minus 2x minus 3 is less than or equal to 2x plus 6 plus x. So if I simplify both sides, I've got 16 minus 2x is less than or equal to 3x plus 6. So subtract 3x, subtract 16, and I get negative 5x is less than or equal to negative 10. Divide by negative 5. X is greater than or equal to 2. So it's greater than or equal to 2. So 2 is my smallest number, and it's going to go to infinity. Questions? Okay, awesome. Okay, so today we're going to talk about compound inequalities, intersections, and unions. A compound inequality is two inequalities joined by the word and or the word or or it has two inequality signs, one on either side of the main problem. So that's a compound inequality. An intersection of two sets, A and B, is the set of all elements that are common to both. So an intersection is one that's common to both. So if I have 1, 2, 3, 4, 5, intersected with -2, -1, 0, 1, 2, 3, it's the ones that they have in common, which is 1, 2, and 3. And this for a compound inequality is the and one. So if I'm doing, if I'm relating it back to my compound inequalities, an intersection is the answer to an and compound inequality. And I do just want to point out this. The sign for intersection is an upside down U. Okay. And then a union of two sets, A and B, is the collection of all elements belonging to A and or B. So everything in both sets, 1, 2, 3, 4, and 3, 5, 7, which is everything 2, 3, 4, 5, and 7. Okay, and this is an or compound inequality. And then the sign is an upside down U. And how I remember the difference, just so you guys know, union has a U and it's upside right U. So that's the upside right U is union. If it's not upside right, it's the other one, which is intersection. Does that help a little bit to tell the difference between the two? Okay. And then the last thing, last definition is the empty set. It's a set that doesn't have anything in it, and it's just a 0 with a slash through it right here, empty set. Okay, is there any questions so far on definitions? Okay, so the first thing we're going to do is just find intersections and unions. So I want to look at what they're asking for first. So they're asking for a intersection because it's upside down U. So where do they overlap? So where do my 2 sets or 3 sets or 4 sets, whatever, how many ever they give me, where do they overlap at? Does that make sense? So what's in both of them? MOP, yep. MOP. Okay, and then number 2, this one they want a union. So always make sure you look and see what they're looking for, if it's an intersection or a union. So union is everything in both sets, so everything. I don't have to rewrite it more than once if it's in both of them, but it has to be in there. So XYZ and UV XYZ. So my union would be UV XYZ. So that's everything. That includes everything in both sets.
Seems pretty solid.
Yeah, it's not bad, right?
I don't. This one has the ones that like are on both sides. This one has all of them, but like only written down. You have to do them both times. So UVXYZ is in all of those units are used in there. The MOP is used in this one and this one. Yeah, that's the same thing, but not because that is used in both. Yeah. But this one would include all of them.
It depends on if it's asking for the intersection. So think of it, intersection as the ones that are in both of them. Only the ones that are in both of them. That's upside down U. That's the first one. Okay. The second one wants everything that's in both sets.
Oh, like everything.
Everything. Does that help?
Yeah, they,
You're welcome. Okay, so on 3, they want an intersection. So what is in both sets? What's the intersection? What's in both of them?
nothing.
Nothing. So that would be the empty set. Yeah. Just like there's nothing. So there's an answer for that. It's called the empty set. Okay? The next one, yeah. So the next one is a union, right? So it wants to know what's in both sets.
1, 3.
So just 1, 3, 5, and then the no set.
Yeah, so if there's nothing in the other set, what's in both sets is 1, 3, 5. Yeah.
Oh, this is lively.
No, don't say that's gonna get hard.
This part doesn't get any. All right, so what are they asking for in A?
Intersection.
The union. Why is it union? Because it's an upside down U. So union is everything in both sets, right? So what is everything in both sets? 20, right? Did I get everything? Awesome. Okay, in set B, they're asking for the intersection. So where's the intersection in number B?
A, B.
There's an A in both terms?
No, it's
Oh,
just
my bad,
D.
bro.
D.
D
I
and
B and D.
I didn't see that.
I didn't see BD.
BD,
I think it's messing with
because you thought it was in the same order as the ones we did above?
Yeah.
Mm.
I think it's my
Milk is out.
Okay, the union of XYZ in the empty set.
XYZ.
XYZ.
I got these.
And the intersection of 1, 2, 3 and the empty set.
None.
The empty set. Beautiful. Questions? Okay, awesome job, you guys. So let's go ahead and go to the second page. So we're going to graph the following and write it in interval notation for each compound inequality. And I do want to say this. If I have a compound inequality, it goes on one graph, not two graphs. How many graphs am I going to draw? One graph. Okay, just one. Okay, so we have this one, and unfortunately, I'm sorry, I need to write a few more numbers on my number line sometimes. Sometimes I have to write a lot more, but on this one, because they have to be even intervals, right? So -8, -6, -4. Good, that's all. I only need those 4. Okay, so on 8 is it open or closed?
It's open.
Open. And on -2, it's
Closed.
closed. Beautiful. And then it says, and then how I read compound inequalities when they're written this way is I start here with the X and then I read outwards. Okay, does that make sense? So this says X is greater than -8. So greater than -8 is this way. And then X is less than -2. So it's here. So it goes right in between. So if I'm using interval notation, I would write parenthesis because it's open, right? -8, comma, -2 bracket. That's it, done.
Oh. Okay.
Huh? Okay, so let's do number 2.
2,
So it was from 8 to
0, 1.
-2, -1, 0, and 1. Because I can't skip from -2 to 0. There's that the intervals aren't even.
Fine.
I'm so sorry.
It's closed.
Thank you. What was I asking? -2 is closed. And it says X is less than -2, which means it goes this way. And then X is greater than 1, which is this way, and goes this way. Yep. So I need to write 2 intervals for this one. Okay, because I have 2 separate arrows. So I have from -infinity to -2 bracket. Good. And then I have 1 parenthesis to infinity. And this is a union. Woo! Because I want everything in both sets, right? Everything in both sets is my answer. Hence, it's a union. Does that make sense?
Yes.
Okay.
I like this.
Yeah, this is an intersection, right? So the first one, if you imagine the arrows really do go past, right? So this line should actually, if it's going from -2, it would go past, and this one would go past, but because I only want the numbers between those two, it's just the intersection. But the graph's not going to show it because it stops at those 2 points. Does that make sense? Okay.
Yeah.
Okay. So if I'm going to do this one,
2, 0, 2, 4.
yep, I'm going to use -2, 0, 2, and 4. Counting by 2s. Is that okay? Yeah, because it's even interval.
Open.
So it's going to be open at -2, and it says greater than -2. And then it says open at 4 and less than 4, so it's in between there. Woo!
C, -2, 4.
Yep, beautiful. And then the last one is an interesting one. So I'm going to say -2, 0, 2, and 4 again. Is that okay? Is -1 on my graph?
Why can't you just do -1, 0, 2, 4?
Because they're not even intervals.
No, 2, 3, 4. 2, 3, 4.
What about 1, 2, 3, 4?
Yeah.
Yeah, you could. I could write a whole lot more numbers on there if I really wanted to. But is -1 on my graph?
Technically.
Technically, where's it at?
The middle.
Is that okay? Yeah, it's okay. So -1, it says it's greater than -1 and it's open, right? And it's going to go greater. And then it's at 4 and it's also greater than 4. So now they all go in the same direction. Oh. But at -4, does it exist?
No.
No. So how many inequalities do I need to write? Interval notations, 2. So I'm going to go from -1 to 4 this time, not included, joined with 4 to infinity. That's it. So it's basically everything between -1 and infinity except for 4. That's what that says. Does that make sense? Okay. So now you guys do it. Go. Thanks. And do this.
Peanut butter or chocolate?
Chocolate.
Peanut butter or chocolate. Okay, so for A, I did -6, -3, and 0. And then it's solid on -6. 6 is Z is greater than -6 and less than 0. So -6 and 0 brackets. Woo. Questions? We okay with that? One, 2, and 3. X is greater than 1 and less than 3. In between again. 1 to 3. Parentheses. Beautiful. Okay. C. -4, -2, 0, 2. T is greater than 2. Greater than or equal to. And T is less than -3. So -infinity to -3. Joined with 2 to infinity. 2, 4, 6. T is less than 2. Or T is less than 5. So on this one, I guess it would be -infinity to 2, joined with 2 to 5. Questions? Are we good?
Yeah.
Not too bad so far? Awesome sauce. Okay, so now we're going to talk about, we're just going to solve and graph. We don't have to write an interval notation this time. Awesome. So solve and graph. There's 2 ways to do number 1, and I'm going to do them both ways just because to help you guys, okay? There's 2 equations written here. There's the one that says, I'm trying to let me stand up. There's the one that says -1 is less than x minus 3, right? And then there's the one that says x minus 3 is less than 5. 2 different equations. Do you see that? If I take off the ends here, there's that one. Oops. And then there's that one. Okay, so you can write it as 2 separate equations if you can't see it. So I'm going to go ahead and write this as 2 separate equations. -1 is less than x minus 3. And then x minus 3 is less than 5. Okay? So what do I need to do to solve? And what am I going to do to get the x by itself?
You are gonna add 3 on both.
I'm going to add 3. And actually, I'm going to add 3 for both equations, right? So I'm just going to do it all at one time. So then I get 2 is less than x, and x is less than 8. Whew. Okay, that one's pretty easy. So that's one way to do it. The other way is if I just take the original equation that was given to me. I don't want to go too high. The original equation that was given to me, which says negative 1 is less than x minus 3, which is less than 5, right? These inequality signs are kind of like equal signs, right? So I have 1 and I have 2. So I have 2 different, if you kind of think of, I know I saw some people like draw those on your paper, right? When you're doing solving. I have 3 different areas. So if I want to get the x by itself, I'm going to add 3 again, but then I have to add it to all of the areas. So that means I would have to add it to this side and this side. So I just do it 3 places instead of 2 places. So then I should get the same answer. 2 is less than x, which is less than 8.
I like that.
It is, right? The problem is what happens is people only forget and do it to one side and not the other side. Does that make sense? So you can, I've seen people draw like dotted lines down to make sure that you know that you've got all 3 sides. That will help a little bit. Oh, thank you. Okay, so that might help a little bit. And then it says to graph it, so 2, 4, 6, 8, wow. Okay, x is greater than 2 and less than 8, so greater than 2, less than 8, right in there. Questions? Are we okay? Awesome sauce. So on an or statement, this is basically an and statement usually when it's got just the 2 written like that. Most of the time, not all the time, most of the time it's an or statement, an and statement, okay? But if it's an or statement, you already have 2 different equations, so I just have to solve them each separately. So on the first one, what do I need to do? Add 7, yep. And I get 2t is less than or equal to 12. Divide by 2. T is less than or equal to 6. Okay. And then on the second equation, what do I need to do? Minus 5. And I get negative 2t is greater than negative 2. And then I divide by a negative 2, so I get t is less than 1. So remember, I divided by a negative number, so my inequality sign needs to switch, yes?
Yeah.
Okay, so when I'm graphing it, 0, 2, 4, 6, less than or equal to 6, just this way, less than 1, which is also this way. So that's the graph. I don't have to write it in interval notation, so I'm done. Questions? Awesome sauce. Okay, so on number 3, I'm just going to do it as is instead of writing it as the 2 separate equations, but if you feel you need to, they would be negative 2 is less than or equal to x plus 2 divided by negative 5, and x plus 2 divided by negative 5 is less than or equal to 6, right? So those are my 2 equations. So I have my 2 columns here. And what do I need to do first?
Multiply negative 5.
Multiply by negative 5. Beautiful. So I'm going to multiply by negative 5 there, there, and there. So that means I'm going to get 10 is greater than or equal to, because I multiplied by a negative number, so my sign switches. X plus 2, sign switches, greater than or equal to negative 30. Then I'm going to subtract 2. You guys know how to do this. 8 is greater than or equal to x, which is greater than or equal to negative 32. Ugh, okay. Negative 32, negative 24, negative 16, negative 8, 0, 8. I guess I didn't have to quite draw it that long. So it says on 8 I've got a solid dot, on 32 I've got a solid dot. X is less than 8 and greater than 32, so it's right in there. Boom. Questions? Not bad? So my interval's 8. I counted by 8s. Is that okay? Because if I read from in this way, right? This says X is less than 8 and X is greater than negative 32. Are you okay with that?
Yeah.
Are you sure?
It's okay.
Positive?
Yes.
Okay. These ones, sorry. So, I guess we are graphing them, aren't we? I'm gonna subtract 5, and I get negative 3a is less than or equal to 3. Divide by negative 3, and a is greater than or equal to negative 1. Subtract 1, 2a is greater than 6. Divide by 2, a is greater than 3. So negative 1, 0, 1, and 3. Wow, that was not very good. Don't laugh at my intervals, they're bad. A is greater than negative 1, and a is greater than 3. So there's that one. You divided by a negative number, so the sign switched. Oopsie. Okay, and then on B, subtract 2, and you get negative 5 is less than or equal to X, which is less than 7. Oh, Lord have mercy. Negative 5, negative 3, negative 1, 1, 3, 5, 7. X is greater than negative 5 and less than 7. That's open dot. Less than 7. There we go. Okay. There you go. Right at the bottom of your page, change a little bit from your page because we're not doing, the lesson is in Canvas, not Delta Math. And then we have a checkpoint next class period. On 2-1 and 2-2, yes.
Wait. Okay. What's 2-1?
Just single inequalities. It's what we did in last class. Oh.
Maybe I won't fail this. Yeah, this would be a letter.
Just inequalities. Solving inequalities, okay?
So what do we do for 40 minutes?
Homework. If you need a computer, I have 5 of them. So you can go in and I have some computers if you want a computer. Yeah, go in and if you can get your homework, get it done. Right? There's 14 problems, I think. 13 to 14 problems.